Yes, so to anyone already here in the room, 12 people, I think, if I understand the UI here correctly. I created a poll, so you can submit your vote if you already know test containers or not. Depending on if people know it already or not, we can shape a little bit the focus of the presentation. But I will assume folks are not yet knowing it, so it will be a little bit more general, therefore. All right. So as per my timing, we can get going. We can slowly start. So I will do so. I'm already sharing the screen. I'm moving my windows here around for the presentation. And all right. Good morning. My name is Kevin Wittek. I will talk to you about integration testing and how integration testing can become more easy and more accessible for everyone through using test containers, the test containers open source library, and Docker containers. And if you have any question during the talk, just reach out in the chat during the talk. I will try to answer them, or maybe I can even pull you into the stream so that you can phrase your question yourself. We can try this out. So yeah, best to have some interactivity going on during the session. I'm always happy about this, so don't refrain from asking questions. My name is Kevin Wittek. I'm the open source lead at AtomicJar. AtomicJar is the company that is now behind the development of the test containers open source library. But test containers indeed started out as a purely open source project. And just recently, we founded the company AtomicJar to also create a business model that can support the open source development. So we are working on products that not really extend, but that have synergies with test containers so that you can use test containers in different ways through our product Test Containers Cloud, for example. But today we are talking completely about the open source project and the concepts behind it. And yes, everything you will see is open source and you can use it in an open source way. I'm one of the maintainers of the Test Containers open source project. Oracle ACE, and there are also some courses from me on LinkedIn Learning on Java and blockchain and other topics, but they are only in German. Sorry, so I don't know if this will be helpful for you. That's of course a side note. I'm from Germany. That's why the courses are in German. So when we talk about integration testing, one of the big issues is that the term integration testing is not that nicely defined across the community, across the industry. And actually, the term unit testing, which we all have kind of a base understanding of, even this term is not really understood well and understood the same way across different developers, across different teams. Therefore, I like to a little bit talk about the history of the concept of unit testing and the term unit testing and where it comes from, because it's very interesting and gives you a lot of perspective and context, I think. And one really good source about the history of the concept of unit testing is indeed Kent Beck. Kent Beck, the person behind extreme programming, behind TDD to a certain degree, behind the original JUnit framework. And he is one of the key figures that brought the term unit testing and some of the technical concepts of unit testing into our industry. And it was very strongly informed by Smalltalk and the Smalltalk community. Because in the beginning, Kent Beck was a Smalltalk developer. Smalltalk, one of the languages that really brought this object-oriented programming paradigms into broader use. And Smalltalk, so he says in this podcast interview, he says that Smalltalk had a very rich testing culture already. But back then, the testing was a more manual process. And indeed, in Smalltalk, you tend to have a stateful workspace. That is something very similar to other environments from today. Like if you've ever used something like MATLAB or R, you will find a similar concept there. So meaning if you have functions that write to certain variables or whatever, this is a stateful workspace. So you can then always inspect the state of this variable. So it's a very iterative, interactive way of developing. And that's how people tested. So they run code, they asserted by themselves by looking at the state of the workspace, how the code changed certain variables and so on. And that's how they did testing in a very manual, interactive way, in a very developer focused way, which is of course very fine. And now he thought, okay, how can we put these manual concept into object-oriented paradigms? And that's how he developed a basic unit testing framework in object-oriented way for Smalltalk. That was in 92. And there the workspace becomes the class, the variables of the workspace become instance variables in our instantiate class in the object. The tests you would normally run by hand are now the methods of our test class. And instead of printing out state or checking state manually, you're using assertions. And that's the starting point, the seed of unit testing frameworks, how we know them today. This Smalltalk testing framework was then also introduced by Ken Beck in the famous C3 project. He joined in 96. The C3 project is, of course, famous mostly because it was the first project done in extreme programming style. And then at this time also Java came up, and there is this famous story how he on a flight to the Uppsala conference together with Eric Gamma in 97 developed the JUnit, the first version of JUnit, in a completely test-driven development fashion. And then when they arrived at the conference, Martin Fowler was also there. They gave him the first version of JUnit, and Martin Fowler said, okay, that's kind of cute, that's interesting, let's look into this. And that is really starting point of all those XUnit frameworks we have nowadays in most languages, definitely in all the modern object-oriented programming languages. All right, and so we know already Kent Beck did the development of the JUnit framework in a TDD style, test-driven development, and he's of course one of the big advocates for test-driven development, in a way one of the founders of this idea. And so when he talks about TDD, he already acknowledges that it's important to test at very different scales. And he explicitly states that test-driven development is not a unit testing philosophy. It's a testing philosophy and a design philosophy. And therefore, he's very pragmatic about at which scale, at which abstraction the test should be written. So he said, write the test at the level or at the scale where it makes the most sense to get the best progress of your code driven out using test-driven development. And then if you look at JUnit itself, and so we know from him, JUnit was developed using a TDD approach. He says 30% of the tests are tests through the public API. And these are tests you would generally not classify as traditional unit tests. You would nowadays tend to classify them as maybe functional tests, maybe they are integration tests, maybe they are out-of-process tests. It depends on how they actually then execute. But they are not those very classical minimal unit tests with a lot of mocking many of us take for granted when they think about unit tests. And I find this very interesting. And then something interesting they discovered Beck and Gamma while they were doing consulting, and they wanted to do consulting to have a better testing culture for developers and also a better TDD culture. And there they wrote this small paper, and it's called Test Infected Programmers Love Rating Tests. And so this is like the late 90s, the early 2000s, a time when it was not normal that developers would write tests. And this is now a nice quote from this paper. Every programmer knows they should write tests for their code. Few do. The universal response to why not is, I'm in too much of a hurry. This quickly becomes a vicious cycle. The more pressure you feel, the fewer tests you write. The fewer tests you write, the less productive you are, and the less stable your code becomes. The less productive and accurate you are, the more pressure you feel. Programmers burn out from just such cycles. And that's maybe also how some of us tend to feel in their projects, in their day-to-day projects. They are accumulating technical debt. They are not able to write more tests because they feel the time for them, they don't have the time for them, although writing tests would actually increase development productivity in an ideal way. And now they have their conclusion. We found the outside influence we needed in a simple testing framework that lets us do a little testing that makes a big difference. Okay, so we now have to remember this is late 90s. This is a time when testing was done a lot by testers, a lot through different tools that were not integrated with the actual development workflow and the actual programming languages the developers were using. So now they say by introducing JUnit or other XUnit frameworks as this very developer friendly testing tool, testing became so much more accessible to developers that they started to think about testing as a way to make themselves more productive during development. And this is a fundamental shift of thinking about testing. And yes, so here they said this outside tool was necessary to create this shift in thinking, using testing as something beneficial for you during development. And yeah, why do we test? Why do we test? Folks might have very different reasons why they would test, but also given these are some of the answers you might get if you ask people why do they test, and if you want, just write into the chat why you are testing, maybe. And some might answer to find bugs, or after bugs were found and the bugs has been fixed to safeguard against future regressions where this bug might be introduced. And some just test because the boss or the management or whatever said they have to write tests. They have to create a certain amount of line coverage through the tests. Some even don't write tests because they feel developers are not supposed to write tests. And in my opinion, the best way to approach testing as a developer is use testing to get feedback about your code during development. The easiest way to get feedback about the correctness of your code in a very comfortable way, very highly automated. That's why I love writing tests during development, because that's for me the easiest way to understand if what I'm programming is actually correct. And in line with this, this is, I think, the wrong reference at the bottom. This is from a blog post from Fowler. So sorry for this, but so the best time to write tests, the highest return of investment, as per Martin Fowler, is in this nice quote: whenever you attempt to type something into a print statement or a debugger expression, write it as a test instead. That is a nice rule of thumb. It's a good way to start thinking more in a way of tests helping you to develop. And accordingly to this, the best return of investment for writing tests is during my actual development and then debugging, because writing an automated test is most of the time the best reproducer for a certain bug. And then you can use this test to drive your debugging effort. And of course, it's completely fine to also attach debuggers, inspect state. That's also what I do and like to do. But driving the reproducer through an automated test, that's super comfortable. That's very nice. So we were talking about unit tests and how, in a way, Beck introduced this concept and this idea through his work on XUnit. And I tried to look a little bit further into the history of testing and testing terminology, and I tried to understand when was the first time unit testing as a concept came out and the definition of the term unit. And it's not that easy, and I was not super successful in finding the first occurrence, but probably one of the first occurrences is in a paper, Automatic Software Test Drivers, that was released in 1978. And this paper references an IBM manual, the manual for the automated unit test system. And I could not find this manual, but this seems to be really one of the first occurrences of unit. And I'm not 100% sure what in this system unit refers to, but from what I understood, the unit is the test unit you execute. So it's not the system under test. That is not the unit in this case, but the code you can execute as a single unit to execute a test. So it's like the little bit different way around to think about it. And then there is a quite famous book in the testing community, The Art of Software Testing, first released in 1979. Then we have a chapter, it's about module testing, and the concepts are very similar to what we think about nowadays as unit tests. In the 90s, we have then the growing of those XUnit frameworks, also through the Agile community, extreme programming community. And there we also have different ideas what unit means. Sometimes unit is the code under test. Sometimes unit is the test code that can be executed. And then something interesting happens in 2004. The second edition of the Art of Software Testing book comes out. And here we have a chapter on module, still the chapter on module testing, but it gets renamed to module unit testing. So it seems that's how the term unit crept into our nowadays understanding and definition. Good. So we learned a little bit that the term unit testing is very, very fuzzy. And then there is something we see occur very often when talking about unit tests, integration tests, different scales of testing. This is a testing pyramid. And there has been another pyramid before that likely was the metaphor that was used as a base for the testing pyramid. And that is the food pyramid from the United States Department of Agriculture. So this is not a really scientific model, but it has been developed and published by the Department of Agriculture. So there are some economical incentives behind creating this kind of pyramid. And of course, nowadays we know this pyramid is not scientifically accurate. It was more or less just used to drive the narrative that agricultural products are very, very healthy for you, and that are the products you should consume most of. So very interesting. And yes, so I have the hypothesis. This food pyramid is the basis for the test pyramid metaphor. We will see a little bit of the reasons later. When was now the first time this pyramid appeared in the context of software development? I think that was the first occurrence I found, that it first was brought into the community through mycone, probably around 2003, because there is the recollection from Martin Fowler of an event where mycone showed this to Lisa Crispin in 2003. And this is already looking like this unit testing pyramid we might have in mind. So we have at the bottom the unit test, and at the middle we have something called certain, and we have the UI test. And this was much more explained than in mycone's book, Software Development Using Scrum from 2009. There he explains a little bit what the different layers also mean. So the UI is something like Selenium test. Service is testing through some kind of API that is not an UI API, and he gives us an example, tests written in a framework such as Cucumber or Fitness, and then the unit tests are the tests that are executed through, for example, JUnit in the case of Java. Now, the important thing about why this was a nice metaphor at this time was that it is a time where people try to push those agile methodologies, the agile methodologies of writing tests and increasing also the technical quality of your work. And before we had those push from the agile community, there was the narrative in the industry, maybe also in management, that tests tend to be expensive to write. Why? Because traditionally testing was more considered in the realm of end-to-end tests and UI tests. So there wasn't a distinction of the different levels of tests you have and how those different levels have different advantages and drawbacks and different implications to maintenance and such. So that's why this metaphor of the pyramid was pushed. And it was supposed to say, yes, some tests are expensive to write and maintain, like the UI test. That's why we just have some of them. But the unit tests are easy to write, cheap to execute. Let's have a lot of them. So this is a metaphor to also convince management that it's fine for developers to write tests. At 2006, we also had a similar pyramid drawn by Jason Huggins, the developer behind Selenium, the inventor of Selenium. He called testing pyramids for web apps. It was drawn on some piece of paper or whiteboard somewhere. Also, like very, very mythological where it occurred. And now here is where I thought it's very likely motivated through the food pyramid metaphor, because it says at the top, UI tests salts and fats used sparingly. And that, of course, reminds us completely of the food pyramid. Besides, it's a similar concept as we know from Mike Cohn. Mostly the different layers are defined by the test driver. UI test, smoke test, the top driver, driven by Selenium. Functional test, middle layer, something we nowadays like to call integration test, is driven through something like doc test, fit, or fitness, very similar to the cucumber idea of Mike Cohn. And then at the bottom, the regular unit tests. They're unit tests because they are executed by PyUnit. Very interesting that back then the layers were defined through their drivers. Martin Fowler, 2012, a blog post that adds a little bit more context to the layers. That's why I like this diagram a lot. He says the pyramid is based on the assumption that broad stack tests are expensive, slow, and brittle, compared to more focused tests such as unit tests. While this is usually true, there are exceptions. If my high-level tests are fast, reliable, and cheap to modify, then lower-level tests aren't needed. So I really like this context that is added here to this pyramid. It says, okay, this pyramid shape, it makes sense when these assumptions hold true. If your UI tests, if your service tests are easy to write, fast to execute, okay, then don't branch out in all those small unit tests. Just write more of those. I like it a lot. 2014, we have from Simon Brown, the testing house. He says the issue with this classic unit and integration test levels is that they are very, very fuzzily defined. People confuse it. People argue about what is unit test, integration test. So he tried to not connect it to the driver, but to the component or to the code that is under test. And then he just says, okay, the bottom are class tests. That's if I'm testing a single class. And then if I'm testing an actual component or service, let's call it component or service test. And then top, if I test the UI, it's a UI test. If I test the public API, it's a functional test. And he already acknowledges there doesn't have to be this pyramid shape anymore. It might be fine that we have as much class tests as component tests. I think it's very good that he tried to bring more clarity into the definitions. However, he failed with this because no one of us uses this pyramid house and this concept of the pyramid house to talk about testing. We all have the testing pyramid in our mind. But we now increasingly see indeed a change of thinking about integration testing, unit testing, and that's in part also motivated by microservice architectures. And we have this interesting blog post from Spotify, also by now from 2018, a little bit older, testing Honeycomb. And here they say very clearly for their microservices, the test suite, it consists mostly of integration tests. And what are for them integration tests? That are those tests that interact with databases, etc. They call those integration tests. It's testing the integration of my service with another third-party component. And they say they have most of those. They don't want to mock them because they want to have a high abstraction away from the implementation details in their tests. They want to be able to refactor a lot. Then they have few of those implementation detail tests. These are the very classic unit tests, you would say. And they have some tests they call integrated tests. This is a very nice way to think about tests. It means tests that pass or fail based on the correctness of other systems. These are mostly the case if you are testing in a shared staging environment. And they say, these are an anti-pattern. You maybe need some of them, but you should avoid having them, because if those tests fail, you can never know. Did they fail because of your system or did they fail because of the other system? And their pure integration test, they say, give you a high confidence that it's about not the other system, it's about your integration with the other system. So then you know you made an error. And indeed, in this blog post, they explain how they are able to have such nice a reliable integration test, and that's by using test containers. So they use test containers for this concept. And also makes a lot of sense in the context of microservice, because a microservice has a high integration surface as compared to its core, logic core. So especially compared to a monolith might have a bigger logic core with a less high integration surface in relationship to the core. That's why it's very, very natural to transition into such a test suite shape for microservice architectures, in my opinion. And this idea has found some traction in the community. We have other companies advocating for similar test suite distributions that work very well for them. Here we have Asaf, who is talking about the diamond model they were using at Logs.io, with similar reasons, saying, okay, like testing the microservice in an integration test way gives just high confidence to the developers that what they are doing is correct. And from the JavaScript community, we had something similar appear. So the top, it's basically the same honeycomb. But the nice thing that they also add the concept of static type checking. And of course, this is a JavaScript community, so likely a narrative that is informed through ideas of using TypeScript type system to catch certain classes of errors. And indeed, that's true. If our language has certain features already built in, or our compiler has certain checks already built in, then this is a certain class of tests we don't have to write ourselves. The compiler does for us. And it's nice to think how this in a way extends the test suite to find certain error classes. Okay, all in all, as a summary of this, what is for me the realization is that tests are a very multidimensional thing. And just thinking about them in terms of this test pyramid as a one-dimensional scale where you go from unit to integration to UI test, it doesn't really capture the complexity of testing. And yeah, we also saw unit and integration test, very fuzzy definitions. People can have, and teams can have very different definitions of those. So instead, other dimensions we can clearly identify in our tests are closed box versus open box tests, meaning is my test able to inspect inside state of the system, or can it only look at the state from the outside through public interfaces? The other aspect is my test running. It is the same process as my code under test, as my system are under test, or out of process. An example is, for example, in Spring Boot, if we have a classical Spring Boot test, our test code is executed in the same JVM process as our Spring Boot application, as a Spring Boot context. We can directly interact with our beans, as opposed to something like a REST assured test, where I would interact with my system through its public REST API, basically going over the network I/O. And then another nice concept from Martin Fowler, again, I'm advocating this here, is thinking about test as sociable test versus solitary test, especially in the context of unit test. So if you have a test where you strictly mock out all the collaborators, that is a solitary test, versus when your object is using other objects as collaborators, it's more a sociable test. Okay. For me, in a way, how I define integration tests, also in the context of test containers, these are the tests that interact with external systems and external dependencies. Most of the time, that means interacting with another process. And this is done most of the time over the file system. This is done most of the time over the network. Over the network, we're talking with another process, but it could also be over a Unix socket or something. And yeah, interacting with a file system, another example for an integration test. And the classic examples are databases. If you interact with a database, if you interact with something like a Kafka, these are the integration tests. Martin Fowler has an even different spin of it, and he talks on the interaction with external components in unit tests. If talking to the resource is stable and fast enough for you, then there's no reason not to do it in your unit test. So for him, if you have an easy way to interact with your database, you would find to still call it unit test. And it's also a nice way to think about it. We don't have to be dogmatic about it, I think. For me, the important thing about integration testing is remembering what Ken Beck and Eric Gamma said about how they made unit testing accessible to developers. Breaking out requires an outside influence. We found the outside influence we needed in a simple testing framework that lets us do a little testing that makes a big difference. And I think something similar is needed for integration tests to be more accessible to developers and to make developers more productive maintaining, writing, and running integration tests. And now I say an open source tool such as Testcontainers is a very, very good approach and can be such outside influence that makes integration testing more accessible to developers. So how does it look if I'm now using Testcontainers? Testcontainers provides an object-oriented API or an in your programming language API to set up your test environment, basically to instrument Docker containers. And here in this example, we see how we can start Redis. So we just create a new object, specify the Docker image we want to use, configure it through the setter, like saying, okay, this port should be exposed, then we can start it, and then we can stop it and it will be cleaned up. And I can now, of course, add this code into my usual XUnit test code. And that means I now have the definition and the setup and the instrumentation of my test environment next to my actual test code. That is already very nice. That makes these setups much more accessible for the developers. You can do it from the same IDE while he's writing code. It will be able to run locally because it will start the Docker containers locally and so on. Another important part, this starting command, it does more than just a simple Docker run command, because it will also ensure that the application in the container is ready to be used in the context of the test. And how does Testcontainers do this? It has different strategies, so-called wait strategies, that check for readiness. And in this default case, it just checks that it can open a TCP connection to this port that gets opened here. And in case of Redis, it is enough. As soon as Redis is ready to be used, it will accept TCP connections. And then when you stop it, a cleanup will happen automatically, so you don't have to care about dangling resources or anything. Testcontainers takes care of this cleanup. There's also integration in test frameworks directly. You can use, but you don't have to use. So we saw before we have to start and stop the container. Instead, here is the JUnit 5 integration. You can just annotate your class with the Testcontainers extension, annotate the container fields you want to be managed by the extension, and then it will be Testcontainers will automatically start the container before the test method and stop it afterwards. Or if it would be a static field, it is on a per test class basis. And sometimes that is good, but most of the time be careful with this, because starting a container much cheaper than starting a virtual machine, obviously, but it still requires to start the application inside the container, so it might take some seconds. And this is an overhead you likely want to avoid in bigger test suites. So it's in bigger test suites, it's much better to reuse the same container across tests if this is possible. Okay, some news, some facts about the Testcontainers project. It started out as a Java open source project, Testcontainers Java, which has been released in 2015. And it's 100% open source under the MIT license. Over 600 releases. We have nearly 400 contributors from the Java community. It's used by over 10,000 projects on GitHub. A lot of other open source projects use it internally for testing. For example, Spring Data uses it, and many others. Over 6,000 stars, which is quite okay for a Java project. And we are currently having these 4 core maintainers. Richard here in the middle, the picture from my wedding. It was the first and only time we 3 met together at the same location. And then we have Sergey on the left, and Richard and Sergey founded together AtomicJar. And then me, that joined as a third person to the project. And we have also now Edu as a maintainer of the Testcontainers Java project. So, but if you are not in Java, we also provide support for other languages that is increasingly getting better and to the same quality level as the Java one, the same feature set. Most notably, we have now very good support for Go and .NET through those two maintainers here, Manuel and Andre, that also joined AtomicJar as open source maintainers. And then we also have basic support for Python, Node.js, and Rust. Okay, so yeah, these are the three main languages and how the stars develop. So we see especially .NET is getting a lot of traction. It's interesting to see also the .NET community adopting test containers, while clearly in the context of Java, it's the most established project so far. And it's also used by a lot of companies. It's used in the open source context. It's used by commercial companies. So we saw already Spotify had the blog post about it where they mentioned it. But we know JetBrains use it, Netflix use it, many big companies use it, sometimes contribute also to the library for certain use cases. It's very cool. And yeah, accordingly, we also, as an open source project, have very nice sponsors. So thank you to all sponsors from companies, from the community that help us with this. We recently got some this open source accelerator funding sponsoring from GitHub, which was great, from Red Hat, Spotify. But of course, also like the other recurring sponsors, very happy about them. Cirrus, Vivi, Juke, the database library also uses it internally, Backbase, Elastic, and all the individual backers also thanks a lot to all of you. So we quoted Martin Fowler quite a bit in the talk, and he is of course working at ThoughtWorks, and test containers recently appeared also on the technology radar, ThoughtWorks technology radar, and we are now in the adopt category, which is pretty cool. So what they say is, we think it's a useful default option for creating of reliable environments for running tests. Our teams have consistently found this library of programmable, lightweight, and disposable containers to make functional tests more reliable. And that's, of course, very nice. Yes, so I'm not going over the specific different features because I want to at least show a quick live demo. These are the features. These are specific modules that are already available in test containers. So we have readily configured modules for things like Postgres, local stack, Kafka, etc. But let's have a look at some actual code to see what can happen there. Let me switch the sharing to IntelliJ. If you have any question, put them in the chat, please. I try to answer them before we run out of time, which we will do soon. All right. Okay. So this is a Java project. This is my Gradle file. And if I want to get started using test containers, I just add a Java dependency, just like any other usual Java dependency. The current version is 1.17.6. And we publish the different technologies as different modules. That's why I'm using this bill of materials here. And then we have, for example, the Kafka module, Oracle module, Postgres, whatever. And the core module is just called the core module. And it would be the same if you're using Maven, of course. Now I have here a simple example project that doesn't use any framework code. So it is about just saving books in a relational database. Yes, it just have two fields. And in this book repository, we just use plain Java code to save books with Java SQL code. The production code here is not really important. It's just supposed to be a simple example. And we have another class here that can send notifications to Kafka, to a Kafka topic, which basically just means sending messages to Kafka. Now, the interesting thing is that we want to look into testing those classes in an integration test way. So this is our book repository test. So we want to test that an empty repository is empty, that it contains a book after saving a book, and that we can search books. And now let's look at the test containers code necessary for this. We are using here the specific Postgres module. So then we have already this abstraction of Postgres container. We just have to specify the Postgres image, no much more configuration necessary. I'm then using in my before each here a flyway to bootstrap the database schema. And here we see this Postgres module gives us a couple of handy convenience method, like getting already the JDBC URL. Why is this necessary? Because test containers will always dynamically bind to a free port. It's like using the Docker publish feature where you specify, okay, I want to publish port 5432, and then Docker will just go ahead and bind it to any free port. And that is really, really good and really important, because you don't want to bind to a fixed port. If you would bind to a fixed port, you end up with an integrated test again, because now your test might fail if this port is already in use. So that's not something you want to do if you want to write integration tests that are very maintainable and very portable. You don't want to make too many assumptions about the environment you are running in. And yes, that's why the paradigm here is always, after the container has been created and started, you should get the actual map port and inject it in your system under test to work accordingly. So that's what we do here with Flyway, and we do it accordingly with our book repository here. We inject the JDBC URL to be used to connect. So no hard-coded values anywhere. That's nice. We are using Testcontainers extension here to automatically start and stop containers on a per method basis. So let's just run it. Testcontainers works on any operating system. So I'm on Windows here, actually. It works also great on Mac, of course, with Docker Desktop, and obviously on Linux with the native Docker. Okay, so we saw we had to pull the image first. The image was not available on my machine. This happened automatically. That's why the first test took a little bit more time. Now we're running the other tests. They are considerably faster now. So yes, around 5 seconds per test. It's quite okay considering that we are starting a complete new database per test. So this now took 28 seconds. If we run it again, it will be faster because we don't have to pull the image again. And here we see our logs. We see the container is created, the container is starting. So where are the logs? Here. So we see here Testcontainers is starting up. It checks my system, that Docker is available. It automatically configures itself depending on what kind of Docker setup I have. So we have some environment discovery code there that no manual configuration is necessary. In this case, I'm not using my local Docker, but I'm using our product, Testcontainers Cloud, but it would work the same with my local Docker desktop here on Windows. And then we see here the container gets created, the container starts. Starting a container takes roughly 4 seconds for Postgres, which is fine. And now the test already was much faster, but we can make it even better if we now share the container across test methods. It will be even better. Of course, now we have to think about test pollution, and let's not solve test pollution on the infrastructure level by putting a new database every time. Let's solve it on a logical level. Let's just clean the schema between tests. And you can also do different things like rollback transactions or whatever you feel happy with. And now we should see the test is even faster. Instead of 18 seconds, it will be, yeah, whatever, faster. Okay, here, 7 seconds is reported by IntelliJ. And if you bind somehow the container to the lifecycle of your JVM process, just starting in a static initializer, it will be even faster. Whoopsie. Okay, and then let's look at the similar example for Kafka. So here for Kafka, we are also using our Kafka module that abstracts away all the complicated stuff of running Kafka in a container, which is not super trivial since you also need Zookeeper and so on. So we already built this abstraction for you. So just annotate it here. Then we have something similar like the get JDBC URL method, get the bootstrap servers, that will give you directly this Kafka URL with the host under which the container is reachable and the specific map port. And let's run it. Yep, and then we have the second example done. We're also running out of time. So if there are any questions, please put them into the chat. We will see the test succeed now, and then I think we are done. Okay, so if you want to check out Testcontainers more, you can join our website on testcontainers.org. And you can check out our product on testcontainers.com. cloud as well. But as I said, it works with all Docker environment. We saw this test succeeded here now nicely, spinning up Kafka, spinning up Zookeeper, everything we needed in a very transparent way. It works the same locally as it would work on CI as long as you have access to a Docker daemon. And in case you don't have access to a Docker daemon for whatever reasons, consider checking out consider checking out this here, Testcontainers Cloud. It's our product and alternatives to running Docker locally. You can join the waitlist, currently in private beta. Yeah, so that's it. Thank you very much. Seems no questions here. Yes, but okay, thank you. Have a nice day. Have fun with the rest of the conference. Using it with SonarQube, Adama is asking. Yeah, I don't understand the question because SonarQube only displays results from tests or so. SonarQube doesn't execute tests, but you can use it in any kind of CI environment you have, yes. Or do you mean you want to test integration against SonarQube? That you can also do. You can start SonarQube in a container and see the integration interactions with it. Test it. Okay. Then, yeah, SonarQube in a container. Yes, you can totally do it. So anything you can run in a container, you can do. It is as efficient as starting it in a container, yes. So if you have integration tests against SonarQube for whatever reason, because you're writing a SonarQube plugin or I don't know what you're doing, but yeah, you can totally do it. Cool. I wait 1 more minute for other questions, else I will leave you. Else, if you have questions, find me on Twitter or Mastodon, join our Slack. It's on testcontainers.org linked. And we try to help with whatever comes up. All right. Goodbye. Have a nice day.